So what's up, everybody, and welcome back to Jumanji. Good Sunday to you. Let's continue on with conversion. We've done mole to mole, gram to mole to gram. Today, let's try gram to gram. Unlike mole to mole, we do need to find the molecular weight of the element and compound of interest. In this case, oxygen and ammonia. But first, let's make sure we can read and understand the chemical equation before we can go ahead and answer the question. And all this reaction is saying is that when 4 moles of ammonia gas gets together with 3 moles of oxygen gas, it will produce 2 moles of nitrogen gas as well as 6 moles of water gas. And the formula for solving gram to gram conversion, I put it right here. Your compound A is your compound that's given in the question. In this case, we're given 13.6 grams of ammonia. And the question is asking, instead of moles, if you were given 13.6 grams of ammonia, how many grams instead of moles of oxygen would you then need? All right, so let's first find the molecular weight of both. And at this point, we're assuming you're comfortable calculating molecular weight of an element or a compound. So the molecular weight of ammonia and oxygen is 17.0 gram per mole and 32.0 gram per mole respectively. We're staying with our 3 significant figure. Now we're going to take that information, that 1 mole of ammonia is equal to 17.0 grams of ammonia, and we're going to put that into conversion ratio form. Okay, so your conversion ratio for ammonia and oxygen will look like this. 1 mole of ammonia is equal to 17.0 grams of ammonia, and it just shows that what's on the top here must be on the bottom, what's on the bottom must be on top, so you can cancel when the time comes. The same for oxygen. 1 mole of oxygen is equal to 32 grams of oxygen. I replace the equal with a multiplication sign. It does not matter. Shows the same thing, okay? Check, check. We also need the mole to mole ratio for your element and compound of interest. I went ahead and did that. From your equation, it does tell you that 4 moles of ammonia, right, is equal to 3 moles of oxygen. We just took that and put it in ratio form, where your moles of ammonia is on top here and it's on the bottom here, oxygen and oxygen. Now we have all the information we need to fill in our formula here. Let's do that. First, we're given 13.6 grams of ammonia. We'll start there. We're multiplying that by the molecular weight of ammonia, compound A. Even if we didn't know that, right, we have your weight of ammonia here. Guess what goes on the bottom of the side, right? Your weight of ammonia. The only one of these equations that has a weight of ammonia in it is this one, right? And we can remove any side you want and just work with one side of the equation. Doesn't matter. We have your weight. It must be on the bottom, 17 grams of ammonia. Top, the other half of the equation, right? 1 mole of ammonia. Now we have the option to solve this part of your equation before moving on to the next step, or we can just continue filling it in, right? We can remove, we've already used up this part, we will no longer need it. Done here, done here. Next is our mole to mole ratio. So we have mole of ammonia on top. We will have mole of ammonia on the bottom here, right? The only one left with mole of ammonia in it is this one. We know it's going to be mole of ammonia on top because if we had solved this equation, right, we see that grams would cancel, and we left with mole as our new given unit. Therefore, mole of ammonia would need to be on the bottom here. We choose from this one. Again, we can work with any side of your equation you like. 4 moles of ammonia will be on the bottom, leaving the other half of your equation on top. 4 moles of O2, 3 moles of O2. We can now remove this equation. We are done with it, correct? We're done with this as well. Next, we're multiplying by the molecular weight of compound B, which is your oxygen, which is the only one we have left. Right? What goes on the bottom of this equation? We see that we're solving, we're canceling mole here, we're canceling mole here. That means moles of O2 would need to be on the bottom, correct? And the only one that has the mole is the 1 mole of O2, leaving 32.0 grams of O2 on top. We're done with this equation and we're done here. We just need to solve. Doesn't matter how you solve it individually or all at the same time, your answer will be 19.2, 3 significant figures, grams of O2 that is needed to react